How do we define an inverse function? Well, if we look at our Springboard books, page 154, an inverse function is a function that interchanges the independent and dependent variables of another function. Okay, and it says in item 13 we found the inverse for function s of n. We haven't done that yet. But when we talk about the inverse function, a couple things we need to know. First of all, just like it says right here, we switch out the independent or the x variable for the dependent variable and vice versa, which is the y. So with an inverse, we have to switch the positions and the roles that x and y play. Also, a couple things we need to know, just like it says in the reading math section right here. So whenever we see something that says f of x, that means it's the original function. All right, so we put x in and we get that out. This notation here, f negative 1 of x or f inverse of x, obviously tells us this is the inverse of whatever f of x is. Okay, so now let's take a look at how we do this. So use the table below to fill in the steps to find the inverse for f of x equals 2x plus 3. Before we do that, think about what this function is saying. It says if I put a number in, I have to do things to it to get a different number. In this case, if we look at our order of operations, we are multiplying by 2 and then add 3. Okay, so if we were to describe that, that's what it would look like. Okay, so here's how we would do this. Just keep this in mind. So write the function replacing f of x with y. That's easy. That's y equals 2x plus 3. Okay, switch x and y. Once again, easy. It's just notation. That becomes x equals 2y plus 3. Okay. Now solve for y in terms of x. I'm going to streamline this and tell you what that looks like. It's going to look like this. We're going to get y equals x minus 2, or x minus 3 divided by 2. Okay, and then replace y with f inverse of x. So then f inverse of x equals x minus 3 divided by 2. Now let's keep our order of operations in mind here. What we're essentially doing is subtracting 3 in the inverse, and then we're dividing by 2, which is the exact opposite, not only in operation, but also in order of our original function. And there's a reason for that. Okay? That's how we find the inverse. It's basically the undoing of the original function. Let's take a look at how we would go about doing this in order. Let's say I have the function f of x equals negative 4x minus 5. Once again, this tells me I'm multiplying x by 4 and then subtracting 5 from it. Okay, so it kind of gives us an idea of what we should be expecting in our inverse here. So step 1, once again, is to replace f of x with y. So we get y equals negative 4x minus 5. Step 2, switch x and y around. So we get x equals negative 4y minus 5. And now I have to solve in step 3. I have to solve for y in terms of x. That gives me this right here. So we're going to start by adding 5 to both sides of the equal sign. That gives me x plus 5 equals negative 4y. And then I divide everything by negative 4. And I get this equation here. I'm going to switch the side that y is on. That gives me y is equal to the opposite of x plus 5 divided by 4. Okay, so once again, this negative right here. So then that means my last step is going to be just replacing y with f inverse. So f inverse of x equals, once again, the opposite of x plus 5 divided by 4 over 4. Okay, keep in mind here, here's what we do. We have, instead of subtracting 5, now we're adding 5. And instead of dividing by 4, instead of multiplying by 4, we're dividing by 4, which is the undoing of what we originally started with up here. Take a look at another function, f of x equals 2/3 x plus 2. Once again, process is still the same to find the inverse function. Once we get started, we replace f of x with y, so y equals 2/3 x plus 2. Second step, switch x and y around, x is equal to 2/3 y plus 2. And then we go ahead in step 3, the complicated step, and solve for y. So we start by subtracting 2 from both sides of the equation. That gives me x minus 2 is equal to 2/3 y. Now here's a neat little trick here that we probably have not seen yet. When we have to undo a fraction, to get y by itself. Notice that the fraction is 2/3 here. In order for this to clear out, one easy thing we can do is multiply both sides by the reciprocal. So we've multiplied by the reciprocal of 2/3, which is 3/2. And that helps us clear out our fraction. I'm sorry, not 2/3, 3/2. So when we do that, 2 times 3 is 6, 3 times 2 is 6, the fractions cancel. I'm left with 3/2 times x minus 2 is equal to y. And if I go ahead and distribute here, I'm only going to distribute the 3, which means I'm going to end up with, if I switch where y is in the fraction, I'm going to end up with 3x minus 6 divided by 2. And then, of course, my last step 4, which I'm going to put off to the margin here, is to replace y with that f inverse. So f inverse of x is equal to 3x minus 6, all divided by 2. And once again, take a look here. It's a little bit more complicated when we multiply by 2/3. We're multiplying by 2/3 in the original and adding 2. In the second case, we look back to before we distributed here, we're technically dividing by 2/3 because multiplying by a fraction and then dividing by its reciprocal are basically the same operation. And then we have this minus 2 right here. So essentially we are doing the reverse, it's just a little bit more complicated looking. But once again, the inverse is supposed to undo whatever we get here. Last one I want to take a look at is this guy. F of x equals negative 1/2 x plus 4. So in this case, remember it's multiplying by negative 1/2, or technically that'd also be dividing by negative 2, and then adding 4. Let's see what we end up with here. So once again, replace f of x with y equals negative 1/2 x plus 4. Switch x and y around in step 2, x is equal to negative 1/2 y plus 4. And then 3 is solved for y. So I'm going to start by subtracting 4 from both sides. That's going to give me, let's see here, x minus 4 is equal to negative 1/2 y. And then if I divide everything by negative 1/2, or if I multiply by negative 2/1, which is the reciprocal, here's what happens. I get, my fractions cancel out first of all, and I'm left with negative 2x plus 8, which is once again equal to y. Okay? And then my last step is replace y with inverse, f inverse of x. This is going to be equal to negative 2x plus 8. Okay? So in the next video, we're going to take a look at why finding the inverse of a function is so useful.